Okay, today we're going to talk about volume. We've been talking about surface area and all kinds of formulas for surface area. The next thing we're going to address is volume, and so the volume of all these different types of shapes. So for prisms and for cylinders, the volume is just base times height. So if you can find the area of the base, where b is the area of the base, and you can find the height, then volume is just the area of the base times the height. Okay, a couple more vocabulary just to get you familiar with some things. The volume of a cube is just the length of each of its sides cubed. Okay, so if you had a cube and you wanted the volume, I mean, essentially it is still the area of the base times the height, but you can make the shortcut and just say it's just the side length cubed. And here are just some extra things here. These aren't very important, but if two polyhedra are congruent, then their volumes are the same. If you have composite figures, like let's say you have a cylinder on top of like a cone, or a cone on top of a cylinder, then you would just add up the volumes of those two shapes to get the total volume. And then one more thing, this is a principle that we'll look at an example at in a second. If two solids have the same height and the same cross-sectional area, so if I went through and I took a cross-section and I cut a slice of each of these shapes, and I found that the area in each of those slices were the same, and the heights were all the same, then Cavalieri's principle says that the volumes are the same. So we'll do an example that has to do with this scenario at the end. But here's an example. Down here you can sort of see, if I can, there we go. You can see that these shapes are going to have the same cross-sectional area, they have the same height, which means their volumes are the same. Okay, let's look at our first example. So example 1 here asks you to find the volume of the prisms. So we know our formula for volume of a prism is base times height, where b is our area of our base. So let's focus on trying to find the area of the base, which is, in this problem, a triangle. So area of the base is going to be 1/2 base times height. So if I'm looking at this equilateral triangle, the one thing I don't know is the height of the triangle. So let's make a separate problem, figure out the height. If we know that this leg here would have to be 7, and this leg here is 14 because it's one of the sides of the equilateral triangle, we need to figure out what the height is right here. So one thing you should know, if it's an equilateral triangle, then this angle here is 60, which means this one here is 30. So it's a special right triangle. And if you remember your special right triangles, this height, or the middle leg, has to be 7 times √3. Alright, so let's use this in our formula. Area of the base is 1/2 the base times the height. And if we simplify that, area is 294 √3. Whoops. No, sorry, that's not right. 49. 49 √3. Okay, now we still want to find the volume. The volume is the area of the base, which is 49 √3, times the height, which is 6. The height of the prism is 6. Okay, so when you multiply these two things here, you're going to multiply the 49 and the 6 together, and that's where the 294 √3 is coming from. And that's going to be feet cubed. Okay, let's look at the cylinder here to the right. So we want to find the volume, and we know volume is the area of the base times the height. The area of the base, let's talk about that, is a circle, so pi r squared, so pi times 8 squared, which will give us 64 pi. So this one's pretty easy. The volume of the cylinder has to be 64 pi times then the height, which is 6. So volume is 384 pi, and this will be inches cubed. Okay, let's talk about going the other direction. Let's say we have the volume and we want to find one of the dimensions of the shape. So we here in our example 2a, we have a cube. So we know that the volume of a cube is just the side length, or one of the dimensions, cubed. So for this situation, we have our dimension being x by x by x. So 100 has to equal x cubed. Now, ask yourself what you would do to get x by itself. Right now it's being cubed. What you would do is you would take the cube root on both sides. Let me pull up the calculator and I can show you how to do that on the calculator. So if you look on your screen on the left, there is this button where the caret key is. Whoops, I should go to my computer. So if you hit this caret key, Control and then the caret key, it will give you this scenario where you can make this root whatever you would like. So I'm going to take the cube root and then I'm going to take it of 100. And sorry, my computer is set to not round. Okay, so this is going to give us about 4.64 for x. So approximately 4.64. Okay, let's look at part B. So this is a right cylinder. That just means it's not oblique, it's standing straight up and down. So the volume is 4,561. Now that volume is coming from the area of the base, which is in this problem pi times x squared, times the height. So I'm going to simplify that. That's going to be 12 pi x squared equals 4,561. So if you're using your Algebra 1 skills, you would want to get x squared by itself. So I'm going to divide by 12 pi. And so right now I have 4,561 divided by 12 pi equals x squared. And then what would you do to get x by itself? You all know you would square root both sides, right? So I'm going to do this on the calculator as well to get a good exact, or I guess rounded answer. So I'm going to take the square root and then I'm going to put a fraction in there of 4,561 divided by 12 pi. Now you can stop the video and see where my keystrokes were, and then I'm going to round that. So it's about 11. This value here for x is about 11. And that should be in meters. This one before should have been feet. Okay, flip your sheet to the back, just a couple more. Find the height of a cylinder given that the radius is 6 feet and the volume is 486 pi. So this is a cylinder. We know our volume formula for a cylinder is the area of the base times the height. We know the volume is 486 pi. So let's see if we can figure out what we can put in for B and for H. So the area of the base is pi r squared, which is pi times 6 squared. And the height is what we don't know. So we have 486 pi equals 36 pi times h. So you would divide by 36 pi on both sides, and then you would get the height to be 13.5 feet. And give me 1 second. Okay, so let's do the very last one. This one goes pretty quick. All right, we're going to use Cavalieri's principle that says if this is just a volume of an oblique prism, so you're just going to approach this the same way you would any prism. The volume is base times height. So the area of the base is 6 times 11. And the height, they even have it labeled for you. The height of the prism is this measure right here, which is 14. So the volume is 924 meters cubed. Okay, we will do more with volume tomorrow.